All right, this video is a quick mini lecture on synthetic division. So let's say if we had a problem that looks something like this. We'll say we have x to the fourth minus 3x plus 5 divided by, so that polynomial divided by another polynomial of x minus 4. We could use polynomial long division. However, we'd like to complete this using synthetic division. And understanding synthetic division will lead us on to other things that we'll learn within the area of algebra and specifically polynomial functions. So we're dividing by this x minus 4. So we will always use the opposite value of that -4. So if it was a +4, we would use -4, but it's a -4. So we're going to use +4 and put that in our box. We're going to use that. So now after doing so, we're going to use all the coefficients. So the coefficients that are in front of all of these variables. So for instance, that x to the fourth has a +1. And as you can see here, that we're missing x to the third and x to the second. So we have to insert placeholders for x to the third and x to the second. And then we have a -3, and then we have a +5, right? So remember, the placeholders are important because we're missing x to the third power and x to the second power. We put those two zeros in, but we have x to the first power, so we use that -3's coefficient. And then after x to the first power goes to a constant, which it should. So we write the constant down. So now we go ahead and start our synthetic division. The first step is to always bring down that first coefficient all the way down. So we bring it down below the line. And just know that all the values below the line get multiplied by what's in your box. Anything above the line gets added or subtracted to what's above it, and then that value gets put below the line. So we always bring down this first value, which is +1. We multiply it times this +4, and we get +4. Where do we write that? Well, we go up and to the right and write that product of those two. +1 times +4 made a +4. And remember, I said anything above the line gets added or subtracted to whatever's right above it. So +4 and 0 make +4, and we write it down below. Anything below the line gets multiplied by what's inside of the box. +4 times +4 is +16. Anything above the line gets added or subtracted to what's above it. 16 and 0 make +16. And we're just repeating this process over and over and over until we get to the very end. So 16 times the 4 gets us +64. 64 and -3 make +61. And your signs are important. So you see I'm carrying all the signs all the way through, whether they're positive or negative. Now we do the multiplication. Whatever's below the line gets multiplied by what's in the box. So 61, +61 times +64 is +244. All right, so +244 and 5 make +249. And we've come to the end of the road for that problem. Looking back up here in our original, the largest exponent was a 4. Therefore, when we write our answer, we always drop down one exponent. So we'll drop it down to the third power. So once again, looking back up here in our original dividend, x to the fourth power. The fourth power is the largest exponent. So for synthetic division, when it's time to write your answer, you drop down one in value. So from the fourth power, we drop down to the third power. And then we'll just go ahead and use all of those new coefficients that we have. So that 1 goes right there in front of the x to the third power. And then you're just going to write it in descending order. So +4 x to the second power, right? What do you think's next? X to the first power, right? So but you have to insert the plus 16x to the first power, or I can just write plus 16x because you know and I know there's an invisible exponent of 1 right there. And then anytime you have something to the first power, the next thing in descending order, that next term is going to be the constant, so plus 61. And then the last value in synthetic division is always going to be your remainder, always your remainder. So in doing polynomial long division, we write our remainder as positive 249, and we write it over our divisor. Our divisor was x minus 4, so we write it over x minus 4. So then we can go ahead and say this is our answer. So I'll box it in. X to the third plus 4x squared plus 16x plus 61 plus 249 over x minus 4. And of course, in the beginning, that leading term, you can choose to write the 1 or not. All right, let's take a look at another example. So our next example will be 2x to the third minus 3x squared plus 4x minus 1, and that's being divided by x plus 1. So once again, we need to take a look at our divisor. It's x plus 1, right? X plus 1. So in synthetic division, we're going to use our minus 1 and place that in the box. And then we'll go with all of these coefficients. It looks to me that it's going in descending order pretty nicely. X to the third power to the second power to the first power in the constant. So we don't need any placeholders here. So we'll use positive 2, negative 3, positive 4, and negative 1. And then we draw our line. As we mentioned in the previous problem, the first step is to always bring down that first value all the way down below the line. And then anything below the line gets multiplied by what's in your box. So positive 2 times negative 1 is negative 2. Negative 3 and negative 2 added together, right? Because what's above the line gets added or subtracted to what's above it to make a negative 5. We write it below. What's below the line gets multiplied by what's in the box. Negative 5 and negative 1 make positive 5. And then 5 and 4, positive and positive, make a positive 9. Positive 9 times negative 1 is negative 9. Negative 1 times negative 1 added to another negative 1 is negative 10. All right, so once again, if we look at our original dividend has x to the third, right? X to the third. So therefore, in our answer, we're going to drop down 1 to x to the second, and then input that coefficient of positive 2. 2x to the second minus that 5x to the first plus 9. And we have a remainder of negative 10. Our remainder, as we stated earlier, goes above the divisor. Our divisor was x plus 1. So we write the remainder over x plus 1. And that last value in synthetic division is always your remainder. If there is no remainder, then that value will be an actual 0. So I go ahead and box in my answer. And in a quick little nutshell, that was synthetic division. So feel free to just go back and review those two problems. Leave a comment if you have any questions, and I'll be sure to try and answer. Just make sure you like the video and subscribe to this channel and share if you need.